Hello everyone, I am Divya, your math facilitator. So today we will be discussing chapter 8 similar triangles. Okay, so similar triangles is a little difficult chapter for all of you, but we shall make it easy. Okay, chalo, let's begin now. Yes, here it is. Chapter 8 similar triangles. Okay, so firstly, before getting into the chapter, as we are always learning, we are learning the concepts and then we are moving on to the exercise problems. But in this chapter you will also have theorem. Okay, so we learn the concept, we learn the theorem, and then the exercise problems. Okay, and we will learn all the theorems, but BPT we shall learn along with the proof, and other theorem statement is sufficient, and I will also tell you how to learn the statement along with how you can utilize the statement in the given problem. Okay, basically how to apply the given theorem in the problem. Okay, let's begin now. So firstly, let me tell you the concept of similarity. Now, what do you mean by similar? Okay, so we are talking about similar triangles. In your class 9, you have learned about congruent triangles, isn't it? So what is the meaning of similar and congruent? So I'm not getting very deep into the things, but I'll just give you the difference. Okay, because we have to complete the entire syllabus. So let's brush up all the differences. Okay. So what is the meaning of similar? So if I'm talking in case of triangles, so when can I say that two triangles are similar and when can I say that two triangles are congruent? Okay. The first point is common for both the things. Now all the angles has to be equal. Okay, all angles are equal. When two triangles are similar, all angles are equal, and also when two triangles are congruent, all angles are equal. Okay, so this is the first point. All angles are equal. Now the second point where the difference comes is, yes, let me tell you that. I'll change the color and tell you. Second point is, if two triangles are similar, the sides are in proportion. Okay, sides are in proportion. What is the meaning of sides are in proportion? Now say suppose this is triangle A, B, C and this is triangle D, E, F. Now if these two triangles are similar, then you can write AB upon DE. Okay, the ratio of the two sides AB by DE, that this ratio is equals to BC by EF. This ratio that is equals to AC by DF ratio. Okay, if the triangles are similar, this is a symbol of similarity. Then then the ratio of the sides are equal. Now the second point here, if the triangles are congruent, what happens? If the triangles are congruent, then the sides are equal. Okay, sides are equal. Suppose if you have two triangles like, for example, PQR is congruent. This is congruent symbol, isn't it? PQR is congruent to MNO. Then what happens to the sides? They are equal. That means PQ is equals to MN. This difference is very, very, very important. Okay. QR is equals to NO or ON and PR is equals to MO. Okay. I'll just revise it once again. Just see. So when two triangles are similar, angles are equal and sides are in proportion. What is the meaning of proportion? AB upon DE. Okay, this side upon this side. This ratio is equals to BC upon EF ratio. That is equals to AC upon DF ratio. Okay, if two triangles are congruent, then angles are equal. Okay, angles are equal. So when angles are equal, the sides are also equal. Okay, here both angles and sides are equal. Here when the triangles are similar, sides are not equal, they are in proportion. Okay, this is a basic difference regarding the sides you have to understand. In both the cases, angles are equal. Clear? So let's move on to the next concept. So next important concept which we learn in this chapter is BPT, Basic Proportionality Theorem, or it is also called as Thales Theorem. Now what is the meaning of BPT? So here in this theorem, it states that, see the statement, if a line is drawn, okay, the statement is if a line is drawn parallel to one side of a triangle. Now suppose I am drawing a line, okay, this line it is parallel to this side of a triangle. Okay, so this is line, I'm taking it as BE. Okay, this line is parallel to one side of the triangle. Which side can you say? This line D is parallel to BC. Okay, then your BPT states that this line, okay, DE, what you have drawn, DE is parallel to BC. Then what happens? This line divides the other two sides in the same ratio. Okay, other two sides are nothing but AB and AC. Okay, the line is parallel to BC. Now the other two sides are AB and AC. So AB and AC are divided in the same ratio. Where are they divided? AB is divided at point D and AC is divided at point E. Okay, they are divided in the same ratio. That means AD by DB is equals to AE by EC. Okay, that is the same ratio. This is what you have to prove. Clear? Chalo. Okay, so this is what you have to prove. So how shall we prove? For this, let us take small construction. Okay, what is the construction? Here you see, I'm just drawing, okay, from point D, I'm dropping a perpendicular to side AC, and from point E, I'm also dropping a perpendicular to AD. Okay, so the perpendicular points, I'm taking it as F and G. Okay, from point E, the perpendicular is F, from point G, the perpendicular is, from point D, the perpendicular is GD. Okay, and also one more construction is join CD and join EC. So if you observe, there are different triangles which are formed. See here, the first triangle is the upper triangle ADE. Okay, and the second triangle, let us take this triangle in down here in this area. Okay, you have two triangles. What are the two triangles? BDE, this is one triangle, and CDE is another triangle. Okay, so let us make it clear. So BDE, this is one triangle. Okay, this is one triangle BDE, and I'll make the other triangle also clear. This is the other triangle CDE. Okay, so we have three triangles here. The first triangle is the upper triangle ADE. Second triangle is down. You have two triangles. One triangle is BDE. The second triangle down is DEC or CED. Okay, so three triangles. Now with these three triangles, now construction, what will you write? So draw AD. What is the perpendicular? Just see here. So you have drawn perpendicular EF to this side AB. Okay. So EF is perpendicular to AB, and you drew DG is perpendicular to AC, and you also joined, what did you join? You joined BE and CD. So this is what you have done. Okay. Now let's go to the proof. So in proof, so as I told you, you are having three triangles. So we are going to consider the areas of the three triangles. Okay. So what is the area of the upper triangle? Upper triangle is ADE. Okay. Area of triangle ADE is nothing but half base into height. Area of any triangle is half base into height. Okay. So what will you consider as base and what will you consider as height? Now suppose if you are having, okay, whatever is the perpendicular, so this is called the height and this is called the base, isn't it? Yes. So we have drawn perpendiculars EF, okay, onto the side AD. Okay, just see in this smaller triangle, ADE, from E you have drawn a perpendicular. Okay, so the perpendicular is onto the side AD. Okay, so it is half. Base is what? Base is AD and perpendicular is EF. So this is one area. Okay, let's see the next areas of the same triangle ADE. You also have one more perpendicular, isn't it? DG. You drew one more perpendicular. This perpendicular is on base AE. So area of triangle ADE, you can also write it as half. Base is nothing but here in this case AE is a base. Perpendicular is what? Perpendicular is GD. Okay? Chalo. So now you got the area of the first triangle in two ways. Okay, you can find the area in two ways. As I told you, whatever is the perpendicular you're drawing, that is the height and this is the base. Okay, so two perpendiculars you have. So two heights and two bases you will have. Now next let me take the areas of the two triangles which are down. Okay, BD and DEC. Okay, so area of triangle BDE is what? Half base into height. Now here what is the base? Now see this triangle BDE. I'll just draw it clearly. Yes, this is how you have BDE, isn't it? Okay, so this is E, D and B. So this you can see, this is nothing but it's a obtuse angle triangle. See here, this is point D, this is E and B. It's an obtuse angle triangle. Okay, so if you draw a perpendicular to the obtuse angle triangle, it will be outside the triangle. Okay, the perpendicular will be outside the triangle. Clear? So here the perpendicular is from the point E. So here you can see the perpendicular is from the point. See here. So for this triangle BDE, you have drawn a perpendicular from the point E, isn't it? So I am drawing perpendicular from the point E. Okay, so this is D, this is E, this is B, and from this point E, I am drawing a perpendicular. And what is the perpendicular? Perpendicular is EF. Okay, so EF is the height, and what is the base? Base is BD. Clear with this? So EF is height and base is BD. Now let us take the area of triangle. What is the other triangle which is remaining? CDE is also equals to half base into height. Now see this triangle CDE. Okay, you have this triangle CDE in this way. Okay, so this is point E, this is B, this is C. You are drawing perpendicular from point E, isn't it? So I'll just draw it in this way. Okay, I'm just turning the triangle. So this is point D. Okay, so perpendicular you're drawing from point E and this is C. So from this point, if you're drawing perpendicular, what is the base? Base is CD, isn't it? This is again an obtuse angle triangle. Perpendicular is outside. So this is perpendicular. E, F is the perpendicular, isn't it? See here. Oh, 1 second. See here. You are drawing the perpendicular from, just see here. This is triangle BDE. To triangle BDE, you have drawn the perpendicular from which side? You have drawn the perpendicular from E. Okay, now for triangle CDE, for this triangle CDE, so this from this vertex D, you will draw the perpendicular G. Okay, so we shall turn the triangle again to another side. Just see here. So this perpendicular we are not taking. We shall take the other perpendicular. So here this triangle, I am just drawing it in this way. The perpendicular is from point D. From this point D, you are drawing a perpendicular, isn't it? And this point is C and this point is E. Okay, so CE is a base. From this base, you are drawing a perpendicular DG. Okay, this is G. So DG is perpendicular, which is nothing but it is the height multiplied by base CE or EC, you can write your wish. Okay. Now you have these two triangles and these two triangles. Okay, the same triangle ADE, I wrote it in two different ways, area and this we have. Okay, so let's take the ratio of all this. Okay, so let's see what we will get. So I'm naming this as equation 1, 2, 3, 4. Let's take the ratio. Okay, so now let's take ratio of area of triangle ADE upon area of triangle BDE. Area of triangle ADE upon BD, I am taking it as half. This is AD upon EF, and here this is half EF into BD. Okay, these two triangles we have taken. So EF cancels, half cancels. You have it as AD upon BD. Now you might also get a doubt. Why did you take ratio, ma'am? Because here we have to prove the ratios, isn't it? So we are taking the ratios of the triangles. Now also let us take these two triangles, 2 and 4. So area of triangle ADE upon area of triangle CDE. It is nothing but half AE DG divided by half DG EC. DG cancels, half cancels. You have AE by EC. Okay, just see what you have to prove. AD by DB is equals to AE by EC. Here you got AD by DB. Here you got AE by EC. Separately you got. Now you should prove that these two are equal. How will you prove? So there is one small step we will do. In your class 9 you have learned that triangles between two parallel lines. Okay, so now here you can see DE and BC are parallel lines in the triangle, isn't it? See, the bigger triangle is this. So DE and BC are parallel lines. Now in these parallel lines you have two triangles in this way. Okay, so CDE is one triangle and here BDE is one triangle. So the triangle CDE, okay, so triangle CDE and triangle BDE are between the same parallels. Okay, how are the two triangles? They are between the same parallel lines. Okay, and so when they are on same parallel lines and you can see the base is also equal. Okay, same parallels and same base, then the area of two triangles is what? So area of triangle CDE is equals to area of triangle BDE. The two triangles area is equal. So this is the important condition. Okay, now let us go back to what we got. See here, you got this, isn't it? Area of triangle ADE by area of triangle BDE is equals to this. So now let's take area of triangle ADE upon area of triangle BDE is equals to, now area of triangle ADE I am writing as it is, divided by area of triangle BDE is equals to area of triangle CDE, isn't it? So I am substituting, instead of BDE I am writing CDE. Why? Since area of triangle CDE is equals to area of triangle ADE. Clear? But what is area of triangle ADE upon BDE? ADE upon BDE is nothing but AD by BD. That is equals to area of triangle ADE upon CDE is AE by EC. So this is what you have to prove, isn't it? That's it. So basically we are taking three triangles, okay? At the upper triangle and below two triangles. Below two triangles are on the same base and between the same parallel line, so they are equal. Okay, area of the two triangles are equal. And you will take the area of triangles of the upper triangle. You have two heights and two bases. So upper triangle I can write in two ways. Area of ADE I can write it in two ways, and the below two triangles I am writing the areas. How am I writing the areas? Here you see, this is triangle BDE and this is the height. This is triangle CDE and this is the height. Okay, so base is CE and height is DG. Here base is BD and height is EF. That is how you write area of triangles. Now take the ratio of these two and these two. You will get this. But you need to prove that these two are equal. So what is the point you are taking? Area of triangle BD is equals to area of triangle CD. Okay, and you can equate both the ratios. Let's move on to the next theorem. Next theorem is converse of BPT. So what is converse? So BPT says that if a line is drawn, see here, if a line is drawn parallel to triangle ABC, okay, one side of a triangle ABC, then the line divides the other two sides in the same ratio. But here, converse is nothing but if a line divides, okay, proof is not important here, just understand the converse. You may get in objective type. So here, if a line divides, so if the line is dividing, okay, two sides of a triangle, if the line divides two sides of a triangle in same ratio, what can you say about the line? Okay, then the line is parallel to third side. Clear? So here, suppose if this is triangle ABC and this is the line DE. Now DE, so DE is dividing the two sides AB and AC in the same ratio. So AD by DB is equals to AE by EC. Just see here, this line D is dividing AB into two parts and AE into two parts. So ratio of AD by DB is equals to AE by EC. then then DE is parallel to BC. Okay, so this is the meaning of the statement. Okay, here if you can observe, here we have wrote first DE is parallel to BC and you prove this. In the converse, you will write this ratio and you will prove DE is parallel to BC. It's also very simple, but it will not be asked in your exam. Okay, but statement is important. Chalo. So let's move on. Oh my god, it's erased, I guess. So we can also see the next theorems. What are the next theorems? Next theorems are nothing but, okay. So I'll write the converse of BPT again. Don't worry, in the notes I'll provide you. Okay, this one I'll provide you in the notes. Chalo, next theorems you have based on the similarity. Okay, similarity of triangles. You have few theorems based on congruence. Do you remember? If two triangles are congruent, so similarity, congruence, you have SAS congruence, SSS congruence, AA congruence, isn't it? So for similarity also, let's have the same. Okay. So the same thing I can write it as criteria for similarity of triangles. Okay, so here let me tell you what is the criteria for similarity of triangles. So the first criteria is nothing but, so if two triangles are similar, okay, two triangles are similar if all angles are equal. Okay, two triangles are similar if all the angles are equal. Suppose you have two triangles A, B, C, D, E, F. If all the angles, angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F. If three angles are equal, then the triangles are similar. So, if the triangles are similar, I told you one more step. If the triangles are similar, what about the sides? Sides are in proportion. Okay. So, you can say that sides are in proportion. Okay. Therefore, this is the application part. If three angles are equal, triangles are similar. Okay. So then you can say AB upon DE is equals to BC upon EF. The sides are in ratio. Is equals to AC upon DF. Okay. Now the second point is, okay, that this similarity criterion is called angle, angle, angle. Okay. Now this is when three angles are equal. Now the implication part of this, you have angle angle criterion. What is angle angle? If two angles of a triangle are equal, suppose angle A is equals to angle D, angle B is equals to angle E, then also you can say that the triangles are similar. Okay, and you can say that the ratio of sides are equal. How can you say that? See, if two angles are equal, whatever the third angle will also be equal, because sum of all the three angles in a triangle is 180. Do you remember? So this is one special case which you can get it for your objective type. Clear? So angle, 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 and angle, angle criteria is also there. Okay. So next criteria is nothing but, if in two triangles the sides are proportional. Okay. If sides are proportional, if in the triangle sides are proportional, then the two triangles are similar and hence their angles will be equal. When triangles are similar, what will happen to the angles? They will be equal, isn't it? So again, let's take the triangles A, B, C, D, E, F. So AB upon DE, sides are in proportion. BC upon EF is equals to AC upon DF. All the sides are in proportion. Then triangles are similar. Then what about the angles? AD equal to angles are equal. Okay. So this extra part is not there in your textbook, but it's the application part which you will use in the questions. Okay. So here also. So angles are equal, angle, angle, angle similarity criterion. But what happens if two triangles are similar with angle, angle, angle similarity? The sides are in ratio. Here sides are in ratio, triangles are similar. So what happens to the angles? Angles are equal. So that is the application part which you will have to learn. So this is called SSS similarity, side, side, side. Third one is side angle side. So if two sides, okay, so say suppose this is A, B, C, D, E, F. Let's take two sides, say AB upon DE. This ratio is equals to AB upon DE ratio is equals to the some other side ratio. Okay, I'm taking AC. AC upon DF ratio. Okay, and the included angle. Now AB and AC. Between AB and AC, what is the angle you have? Angle A. Between DE and DF, what is the angle you have? Angle D. So this angles, if they are equal, then the two triangles are similar. Okay, therefore triangle ABC is similar to triangle DEF. Now when the two triangles are similar, okay, SAS means two sides are in proportion and one angle is equal. Okay, always remember, in a similar triangle, angles are equal, sides are in proportion. If sides are equal, what happens? The triangles are not similar, they are congruent. Clear? That is the difference. So now therefore what happens? Two sides are equal. So angles, triangles are similar. So what about the third side? Third side ratio is also equal. So you can write AB by DE is equals to AC by DF. These two ratios are equal to the third side ratio BC by EF. And one angle is equal. What about the other two angles? They are also equal. Angle B is equals to angle E. Angle C is equals to angle F. Okay, so these three are similarity criterion. Okay, and next you have area of a triangle concept. Area of triangle. So area of two similar triangles. Suppose triangle, this is ABC and you have triangle DEF. ABC is similar to DEF. Then area of triangle ABC divided by area of triangle DEF. The ratio of these two areas is equals to AB by D. Take the ratio of the sides. Okay, that is equals to BC by EF. All the ratio of the sides to take. All the ratios are equal, isn't it? CA by DF. Okay, the area of the triangle is equal to the squares of the ratio of the sides. The squares of the ratio of the sides. Now when triangles are in proportion, the ratio of the sides are equal. Now for area of triangle, you will take the squares. This is one theorem, okay, but few topics are deleted. While teaching you the exercise problems, I'll tell you only the topics which are there in your syllabus, but I'm just giving you the theorem because sometimes it may happen that you may get it for an objective bit. Okay, so it is important to at least know about that concept. Next important theorem you have 8.5 is uh, 8.5. Before 8.5, 8.5 is not so important. 8.6. 8.6, you see the ratio of two similar triangles is equal to the ratio of the squares of the corresponding sides. Okay, so this is 8.6. Oh my god, this is theorem 8.6. Okay, till 8.5 we have discussed all the similarity criteria and all these are three theorems, three different theorems. These are, I just summarized it together. Now this is theorem 8.6. Now 8.7 is the introduction of Pythagoras theorem. See theorem 8.8. 8.8 is Pythagoras theorem. Okay, it is simple Pythagoras theorem which you already know. I'll just summarize it. Pythagoras theorem. Pythagoras theorem states that if you have a right angle triangle ABC, okay, and right angle is at B, then hypotenuse square is equals to sum of the squares of the other two sides. So this is Pythagoras theorem. Then theorem 8.9, you have converse of Pythagoras. Converse of Pythagoras. Now what is the converse? Converse is nothing but if you have a triangle, okay, suppose this is a triangle. I don't know whether it is a right angle triangle or not. If the sum of, if here it is a right angle, okay, right angle is at B. Okay, now here you don't know it is a right angle. If AC square, sum of one side square is equals to sum of the other two sides. Okay, if you are getting this, then you can say that the angle opposite to this is AC, isn't it? Opposite to this side, what angle you have? Angle B. So angle B is 90, or I can say that ABC is a right angle triangle. Okay, so these are the theorems. I'm explaining you the theorems because you may get it for a objective type. Okay, so all the statements are important. Do learn the statements. We will learn the exercise problems in the next class. Okay, so till then, take care, practice these. Thank you.